Welcome back to another interesting video. Modern car engine control system rely on input from several sensors to regulate engine's performance as well as its emission and other vital functions. When this sensor fail to provide accurate information, the driver may experience increased fuel consumption, drivability problems, emission failure and other problems. One of the most important sensor in modern car is oxygen sensor, also known as O2 sensor because O2 is chemical formula for oxygen. The oxygen sensor monitors how much unburned oxygen is present in the exhaust as exhaust exits the engine. By monitoring oxygen levels, the sensor provides a means of measuring fuel mixture. The oxygen sensor lets the ECU know if the fuel mixture is burning rich, that means not enough oxygen, or lean, that means too much oxygen. Knowing the ratio of air to fuel allows your vehicle's engine to make any necessary changes to ensure that your car runs like it should. So in this video we will discuss about where the oxygen sensor will be fitted in a car, what about its construction, and finally how it works. So let's begin. Now first question is where the oxygen sensor fitted in the car. The O2 sensors are mounted directly on exhaust manifold in between engine and catalytic converter. The sensor that is located before catalytic converter is the upstream oxygen sensor and after catalytic converter is downstream oxygen sensor. Meanwhile, based on their locations with respect to catalytic converter, they are also known as pre-cat oxygen sensor and post-cat oxygen sensor. With the help of pre-cat oxygen sensor, electronic control module decides the air-fuel mixture entered in the engine is rich or lean. And the post-cat sensor provides the details of oxygen in the system after it gets treated by the catalytic converter. Now we will understand quickly what is meant by rich and lean mixture. The lean or rich mixture is decided based on air-fuel mixture in the engine. There are three types of air-fuel mixtures: lean fuel mixture, stoichiometric fuel mixture, rich fuel mixture. Stoichiometric fuel mixture is an air-fuel mixture that contains the exact amount of air required to burn all the fuel in the mixture. For this mixture, air-fuel ratio is exactly 1. This is called as lambda is equal to 1. Meanwhile, lean fuel mixture has more air than the required quantity of air for the complete combustion of fuel. Therefore, this mixture has excess air. These air-fuel mixtures are more efficient but can result in higher temperature. These temperatures lead to the formation of nitrogen oxides. However, some engines are especially designed for this type of air-fuel mixtures to get higher efficiency. We can call the combustion process in this engine as lean burn. While rich fuel mixture has less air than the required quantity of air for the complete combustion of the fuel. Therefore, this mixture has excess fuel. These air-fuel mixtures are less efficient. It is because these mixtures lack the air required for complete combustion of the fuel. However, a rich fuel mixture can provide a very high quantity of energy. However, some engines are especially designed for this type of air-fuel mixtures to get higher quantity of energy. The combustion takes place at lower temperature, thus we will say it burns cooler, or which we will call as rich burn. The key difference between lean and rich mixture is that we use lean mixture for maximum efficiency while we use rich mixture for maximum power in the engine. It is common practice to refer to air-fuel ratio, that is chemically correct combustion, as lambda is equal to 1. If the mixture is rich, lambda is less than 1, probably lambda is equal to 0.97. And if the mixture is weak, lambda is greater than 1. Probably lambda is equal to 1.03. For this reason, the exhaust gas oxygen sensor is often referred to as a lambda sensor. Now, let's discuss what is oxygen sensor construction. It has one sensing element in main body in front of sensor, which is called as zirconium dioxide. The sensing element is enclosed within a steel body. Heater core is placed in between the elements of zirconium dioxide. One air passage is provided in the heater core where atmospheric air can move in and out. Then sensing element further connected to platinum electrode and two wire is connected with the sensing element through the cap, and it will use later to connect it with the ECU. Now let's discuss about working of oxygen sensor. The oxygen sensor normally mounted on exhaust manifold. Exhaust gas consists of oxygen molecules contact the sensing element after flowing through the slots or holes on the steel shell. The outside air or atmospheric air is allowed to flow through the gaps between the connecting cables and enter into the heater core. The air is then heated to enable the ions to produce the voltage. Oxygen concentration of atmospheric air is higher than the oxygen concentration of exhaust gas. That is why ionization will occur in zirconium dioxide diode and electron will flow from higher concentration of oxygen to lower concentration of oxygen. Due to the movement of oxygen ions from one platinum layer to another, a potential difference is generated. This voltage difference will be measured by sensor element, so 0.1 volt to 0.9 volt voltage can be produced during this process. 0.1 volt means air-fuel mixture is lean and 0.9 volt means the air-fuel mixture is rich. These voltage signals are fed to engine control module ECU. Then the ECU compare it with pre-stored standard data to decide whether the mixture is rich or lean. These calculations are used to further manipulate the air-fuel mixture ratio during the subsequent stroke. To sum up, the oxygen sensor is an instrument for controlling the exhaust emission of petrol, diesel and gas engines. It is an oxygen concentration sensor which measures the residual oxygen content of exhaust gas and then transmit a signal to engine control unit in the form of an electric voltage. The oxygen sensor voltage allows the control unit to detect whether the mixture is too rich or too lean. If the mixture is too rich, the control unit reduces the quantity of fuel in the air-fuel ratio and increases if the mixture is too lean. So that's all in this video. We'll see another sensor in next video. Thanks for watching.